Bismillah ar-Rahman ar-Rahim. Now we are going to continue our examples of dynamics differentiation of vector functions. We have an example. A body moves in a straight line according to the relation between velocity and displacement given by v equals 5 over s plus 4 meter per second. Find acceleration at s equals 2 meter. Here we have velocity. Velocity is function of displacement. Then we can use acceleration equals v dv dx. Okay, then we have acceleration equals 5 over s plus 4 multiplied by the first derivative of v with respect to s. Here we have s plus 4 square, and we have here negative 5. Okay, then we have acceleration equals negative 25 over s plus 4 power 3. Okay, then at s equals 2 meter, you can substitute here. Then acceleration equals negative 25 over 216 meter per second square, and this is required to find. We have another example. A body moves in a straight line according to the relation v squared equal 1 over 8 times 4 minus s squared, v in meter per second. Find number 1 acceleration a in terms of s displacement, number 2 minimum velocity of the body. Okay, here we have velocity is function of displacement. Then we can use acceleration equals velocity dv dx. Okay, here we have v squared equals 1 over 8 4 minus s square near ds. Okay, by differentiation, then we have here 2v with respect to s. Okay, s is displacement. Then we have 2v dv ds equals, here we have 1 over 8 times 4 minus s squared all squared, and we have here s. Okay, 2s. Okay, then we have here v dv ds equals s over 8 4 minus s squared all squared. Okay, then v dv ds is acceleration. Then acceleration equals s over 8 4 minus s squared all squared. Okay, this is required in number 1. For number 2, it's required to find the minimum velocity of the body. V minimum is achieved when acceleration equal 0. Okay, then we have here we have s over 8 4 minus s squared or squared equals 0. Then s equals 0. Then we the velocity of the body is minimum when s equals 0. Then we can substitute in the velocity equation. We have v squared equals 1 over 8 4 minus s squared. At s equals 0, then we have here 1 over 32. Then v minimum, okay, equals 1 over root of 32 meter per second, and this is required to find. We have another example. In this figure, it's required to sketch the acceleration displacement as curve corresponding to the given curve vs curve, okay, over this time interval from displacement interval from 0 to 400. Okay, you can choose a as y-axis and s as x-axis. Okay, then we need to draw this curve. Okay, here is acceleration and here is displacement, which is corresponding to this one. Okay, first during time interval or displacement interval 0 to 0 0. Okay, we need to find the equation of this curve. Okay, equation of curve. Okay, here the general form is y equals mx plus c, where m is the slope. Okay, here y is velocity equals slope, x is displacement plus c. When s equals 0, we have v at s equals 0, we have v equals 10. By substitution here, then c equals 10. Then we have v equals ms plus 10. To find the slope m is delta y over delta x. Okay, here we have delta y equals 50 minus 10 over delta x here equals to 0 0. Then m equals 40 over 2 0 0. Then we have 1 over 5. Okay, this is the slope of this straight line. Then we can find the general form of this straight line representing the relation between velocity and displacement as v equals 1 over 5 displacement plus 10. Okay, this is number first step. Okay, then we have to convert this equation to a relation between acceleration and displacement, then by differentiation. Okay, by differentiation, or we can use you have velocity as a function of displacement, we can use acceleration equals v dv ds. Okay, directly. Then here we have acceleration equals v is 1 over 5s plus 10 times dv ds here equals 1 over 5. Okay, then acceleration here equals 1 over 25s plus 2. Okay, this is the equation of acceleration during the displacement interval from 0 to 200. Okay, from this 200 we can sketch this equation, and this relation is like this. Okay, here at s equals 0 a is 2, then at s equals 0 a is 2. Okay, and at s equals 2 0 0 a equals 10. Then we have here 10. Okay, this is the curve, okay, corresponding to this one during the displacement interval from 0 to 200. Okay, during second interval 200 to 400. Okay, here we have velocity from the given curve equals 50. This is constant. Okay, then acceleration equals dv v dv ds. This is equal 0. As the velocity is constant, then acceleration is constant is 0. Okay, then we can sketch here from 200 to 400. Okay, the acceleration is 0. Okay, this is corresponding curve to the given one. Another example, let acceleration as y-axis and displacement s as x-axis. Sketch the corresponding curve to the given one. This given curve representing the relation between v and s for a body moves in a straight line. Okay, first we have from 0 to 2 meter displacement. It's required to find the relation between v and s, or the equation of this straight line. We have the general form of this straight line equals y equals mx plus c, where m is slope of this straight line. Okay, then we have y equals v equals ms plus c. Okay, at s equals 0 we have v equals 2 meter per second. Okay, then c equals 2. Then we have v equals ms plus 2. To find the slope equals delta y over delta x. Here we have delta y is 2 over 2. Then we have 1, but the slope is negative at the angle made by this straight line with positive direction of x-axis is obtuse. Then we have slope is negative 1. By substitution here, then we have v equals negative s plus 2, and this is the equation of this straight line. Okay, now we need to convert this a relation between v and s to a relation between acceleration and s. We have here two approaches we can use. First, here we have acceleration equals v dv ds, as velocity is a function of displacement. Okay, then we have acceleration equals negative s plus 2. Okay, and dv ds equals negative 1. Then we have here acceleration equals s minus 2. Okay, we can also find the relation between acceleration and s by differentiation, okay, with respect to time. Okay, then we have here dv dt equals negative ds dt plus 0, of course. Okay, dv dt is acceleration equal negative ds dt is v. Okay, then we have a equals negative v, and we have v equals negative s plus 2. Then we have acceleration equals s minus 2. Okay, then we have the same equation. We can represent this equation by this sketch or curve. Here we have a and we have s. Okay, when s equals 0, then we have acceleration equals negative 2. Then we have here negative 2, okay, meter per second square. Then at s equals 2, at s equals 2 meters, then acceleration equals 0. Then here 2 and 0. Okay, then this is the curve representing the relation between acceleration of displacement. Okay, here corresponding to the given one, and this is required to find. Another example studies the type of the motion of a body moves in a straight line according to the relation between the displacement and the time given in this curve. Okay, we need to study the motion, then we have to decide which direction in which direction the body moves, in forward direction or in reverse or backward direction. Okay, and as we said during explanation, this is can be decided according to the sign of the velocity. Okay, secondly, we have to identify if the motion is accelerating or decelerating, okay, according to the sign of v times a, okay, the product of va. Okay, of course, if here for this direction of motion, if v is positive, then the motion is in forward direction. It's in reverse direction or backward direction if v is negative. Okay, if va is positive, then the motion is accelerating. If va is negative, then the motion is decelerating. Okay, okay, this is over each time interval in the given curve. Okay, here we have this curve. We can divide this curve into two intervals, time interval, okay, or we can deal with the whole interval. Okay, as here the slope of any the slope of the tangent to the curve at any point during from the time interval from 0 to 7, okay, second is the same. Okay, and the convexity of this curve over the whole time interval from 0 to 7 is the same as well. Then we can divide this time interval from 0 to 3 seconds and from 3 to 7. And in this case, we can also deal with 0 to 7 as the convexity and the tangent, the slope of the tangent to the curve at any moment from 0 to 7 is the same. Okay, then we'll use from 0 to 7. Okay, but if the convexity or the slope of the time of the curve at any moment changes during the time interval from 0 to 7, we have to use two interval from 0 to 3 and from 3 to 7. Okay, in this special example, we'll use 0 to 7, and we can apply it from 0 to 3 and 3 to 7 the same issue. Okay, then from 0 to 7 we have to identify the sign of v and sign of va. Okay, first as we can find the sign of v as we are dealing with st curve, then the sign of v is sign of the tangent, the slope of the tangent to this curve at any moment during time interval from 0 to 7. If we draw any at any moment here the slope of this tangent. Okay, then this tangent, the slope of this tangent here is positive as theta, the angle made by this tangent with the positive x-axis is acute. Here theta is acute. Okay, then velocity is positive as the slope of this tangent to this curve at any moment is positive as well. Okay, then here a motion is in forward direction. This is step number 1. Okay, also we need to find the acceleration as we are dealing with st. Then we have to identify the convexity of the curve over the time interval from 0 to 7. Here the curve is upward convex, then acceleration here is negative. Okay, then we have a is negative as the curve is upwards, okay, convex during the time interval from 0 to 7. Okay, then to identify if the motion is accelerating or decelerating, we have to multiply VA and check the sign. V is positive, A is negative, then we have here negative result. Then motion is decelerating, okay, and in forward direction according to the sign of V, and decelerating according to the sign of VA, and this is required to study. We have another example. For a body moves in a straight line, we have this relation V squared equals 16 minus 9 cosine S, where V is velocity and S is displacement. Find V maximum. Okay, here we have V squared equals 16 minus 9 cosine S. Okay, we can differentiate both sides with respect to S. Okay, then we have 2v dv ds equals positive 9 sine S. Okay, then we have here v dv ds equals 9 over 2 sine S. Okay, as v dv ds is acceleration, then we have acceleration here equals 9 over 2 sine displacement S, and this is a relation between A and displacement, acceleration and displacement. Okay, it's required to find V max. V max can be obtained when acceleration equal 0. Okay, then here we have acceleration equals 9 over 2 sine S equals 0. Okay, then we have here we can find S equals n pi. Okay, now we can substitute in the equation of this velocity. We have V squared equals 16 minus 9 cosine S at S equals n times pi, then V squared equals 16 minus 9 cosine n pi. Okay, here we have cosine n pi equals positive or negative 1 according to n. Okay, now by substitution we have V squared equals 16 positive negative 9. Okay, then we have here V squared equals 25 or 7. Then V equals positive negative root 25 equals 5, or V equals root positive negative root 7. Okay, it's required to find V maximum. Okay, so you will choose the greatest values in V maximum equals positive negative 5 units, and this is required to find. We have another example. In this curve, we have the relation between displacement and time of a body moves in a straight line as given in this curve. Find the corresponding curve to the given one. Okay, from two given curves we have a relation between S and T. It's required to find the corresponding one with the given curves of relation between V and T of this body, which is moving in a straight line. Okay, first we need to study the direction of motion and accelerating or decelerating types of this motion. Okay, then we check again with this one and this one, and decide which two are matching. Okay, are matched together. Then we have to study first the given one. For this one we have here this given curve. Okay, here 1 2 3, and we have this two intervals. Okay, for this one we have relation between s and time. Okay, for the time interval from 1 to 2, from this time interval 1 and 2, okay, we have to find velocity sign. Velocity sign of course here is negative, as the slope of this tangent during the time interval from 1 to 2 is negative, as this tangent makes an obtuse angle with the positive direction of x-axis. Then v is negative in motion, is in backward direction or reverse direction. Okay, this first one. We need to find acceleration as well. Here the curve, as we are dealing with ST, then we have to check the convexity of this curve. The curve is downward convex, then E is positive. Okay, then we have to multiply v and a. V and a equals the negative value. Then we have here decelerating motion, okay, during time interval from 1 to 2. Okay, from time interval during a time interval from 2 to 3. Okay, v is here the slope of this tangent also negative. Then we have also backwards direction of motion. Okay, then we have to find the sign of acceleration as well during this time interval from 2 to 3. Here we have to check the convexity of this curve. Here the curve is upwards convex, then A is negative. Okay, then we have to multiply v and a. Va is positive value. Then during 2 to 3, this time interval, we have here accelerating motion, okay, in backward direction according to the sign of v. Okay, this is a study of the given curve relating the relation between s and t. Now we have to check this curve and then this curve, and check if the type of this curve is matching with this given result or not. Okay, first for this curve during time interval from 1 and 2. Okay, second, for example, we need to find the velocity. Here the velocity is below the x-axis, then velocity is negative. Okay, then we have to find the sign of acceleration. Acceleration in this vt curve is the slope of the tangent to the curve at any instant in this time interval 1 and 2. Then here the slope of the tangent is positive, then acceleration is positive here. Okay, according to sign of v, we have here backwards direction. Okay, and acceleration is negative, then va is positive. Then we have here here positive, then we have here negative times positive. We have negative value is the result of multiplication of v and a. Then we have here decelerating motion in backwards direction, and this is identical to this the behavior of this body during this time interval. Okay, in this given curve until now. Okay, we have to check also the behavior of this curve during 2 to 3 time interval. Okay, from 2 to 3, we have to check the sign of velocity. Velocity is negative as the curve is below x-axis, then v is negative, then the motion is backwards also. Okay, here the slope of the tangent to any point during 2 and 3 here. Okay, here the tangent makes an obtuse angle with the positive direction of x. Then we have here acceleration is negative. Then we can multiply v and a and find the result is positive. Then we have here accelerating motion direction. Okay, then according to this result, this curve the behavior of the motion of this body according to this curve is similar or identical or the same or matched to the behavior of the motion of the body given by this curve. Okay. For more check, we can study the behavior of the motion of this body given by this curve and check if it's corresponding to the motion given according to the curve of ST relation or not. Okay, first here during the time interval from 1 and 2, we have to find the sign of velocity. Here velocity is negative as the curve is below x-axis. Okay, then motion is backwards and this is the same as before. Okay, but also we have to find the acceleration sign. Here the slope of this tangent to this curve at any point during time interval 1 and 2 is positive, then acceleration is positive as well, then VA is a negative sign, then motion is decelerating. Okay, and this is matching also with the previous result. Okay, during time interval from 2 to 3, we have to check the sign of velocity. Here velocity is positive. Here velocity is positive as the curve is above x-axis, then motion is forward. Okay, and this is not the same as a given curve as during 2 to 3. In the given curve, velocity is negative, then the motion is in backward direction, and if we find A also, A is positive. Okay, as the slope of the tangent of this curve during 2 to 3 interval is positive, then VA is positive as well. Okay, and the motion is accelerating as this is not matching to the data given by ST curve. Then the matching curve is curve number 1, which represents the relation between V and T of this body moving in a straight line, is matched to the given curve representing the relation between S and T to the same body moves in a straight line. Now try to solve. A body moves in a straight line according to the relation T equals 3x squared plus 5x, or T is time, x displacement, A acceleration, V velocity. Find acceleration in terms of velocity. The answer is A equals negative 6 V power 3. Okay.